So in this lecture, we're going to discuss about the difference between abstract classes and regular classes, as I told you. And first of all, I'm going to describe what an object and regular concrete class is. Now, a concrete class is a template, as you know, for an object, and using that template, an entity is created, which is the object itself. However, this is not the only purpose of a class. A class can be a template for another class, which means it will not have an object, but it will kind of like serve as a base for other classes. These classes are called abstract classes, and they are actually the standing stones of the concept of polymorphism, because when you create an abstract class, you are expected other class to extend it and then use some of those features defined in the abstract class. In the previous lectures, we gave the examples of animals being listed under there's an animal class, and then each and every one of these animals are actually listed under this main class itself. A good example again is how we can categorize different breeds of dogs. So each dog will be different, but they are belonging to an abstract class dog, which means every one of them is a dog, but then they have their own differences. So you can think of it like that. And in the exam as well, you will be given these diagrams to read them correctly, such as you can see from here, there would be a UML diagram given to you, so that you are expected to read this diagram correctly and generate the Java code based on these diagrams. So you need to understand how an abstract class is represented. A regular class is basically going to be written like that. You see just regular text. And an abstract class, first and foremost, you will see that it is actually italic. Sometimes I also make it bold italic just to make sure that it stands out. This means that this class will never actually have an object, where these classes will have an object. And then, as you can see, the variables and the method of this class will be actually overwritten by the other classes. But each one of them will change its name. So it's like the name will be different for each breed of the dog. The age will be obviously different. And then how they bark is also different. So an abstract class, in short, is a template that how you can form those classes, and it is important to understand this. We're going to do this exercise today so that you can understand this better. Now, in this exercise, I'm going to create what is called a shape class, which will then be allowed to, be extended by different shapes. And then based on this shape class, we'll be able to calculate certain things. Now, to do that, I'm going to go to NetBeans, and I already created a project. I'm just going to maximize this and create my class, just to show you how you can create an abstract class. So I'm going to come in here, say new Java class, and it is going to be a class in here. So I'm going to name it shape and press on finish. Now this is a concrete class, as you can see. It is not different from any other class we previously created. So the first thing I do in here is to put the keyword abstract in front of it. Now, one of the big differences here that you will learn is that this class will never have an object, but that doesn't mean that it won't have a constructor. You can still create a constructor for your abstract class, but these will be used by basically the classes that will extend the abstract class, not the class itself, because this class will never have an object. Now we know from this question that we will have a series of shapes. These are rectangle, circle, and triangle. So we're going to create a series of variables. based upon this. If we want our variables to be passed to the child classes, we can define them as protected. We can say protected integer A, B, and C. Now this means that this class has these variables, but they can also pass to the child classes. Having done so, we can also define different kind of constructors, such as a constructor that only accepts, for example, a value, just one value. And if we want to say this value is R, in this case of a circle, we can say that A is equals to R. So this is my first constructor, just getting one value and then putting into another. Another constructor can be A and B, so integer A, integer B, and this can be this A equals to A, B equals to B. And each constructor, although we don't write in front of them, are actually public. Finally, we can have another constructor for the right angle triangle, which will have three different values, integer A, integer B, integer C. And these can be also written down inside here. A, B, and C. So once you have defined all these values over there, what you could do is that we have now different constructors for different shapes. So if you go back to the question, you know that for the rectangle, there's the A side and the B side. For the circle, we have a radius, and for right angle triangle, we have 1, 2, and 3 angles. So each one of these actually evaluated in the constructors. One of them, one constructor will obviously handle the process. Now, what I'm going to do in this question is to calculate the area and perhaps the perimeter of these shapes. But as you can see, because each shape is different, I'm not aware of what or which method will I use for that specific shape. For example, rectangle, circle, and right angle triangle, they all have areas and they all have perimeters, but the way that these are calculated are different because they are different shapes. So what we're going to do in here is that we're going to go back and we are going to create a specific function, and I will call this abstract. Public abstract double calculate area, and put a semicolon at the end. And I'm going to do the same thing for the perimeter. The reason for this is that I want this specific method to be overwritten by the child classes, and each child will then adopt the necessary method so that they can find the class will find that specific shape's area and perimeter. Now, so far, is it clear what I have done? Good. Now we're going to go into the project, and we're going to create our first shape. Now my first shape will be circle. And as I create circle, as you can see, the first thing I'm going to do when creating the circle is to extend the abstract class. This should be extend shape. As I extend the shape, now I will have to apply certain things. You can see that there are certain methods that you have to implement as you extend an abstract class. Whenever you create an abstract class, all the abstract methods should be implemented by the class that is extending the abstract class. So in this example, you can see that there are two different methods that are defined as abstract. These methods themselves must exist inside Circle. You can write them manually, or you can simply press Alt Enter and say implement abstract methods, and they will come, as you can see, automatically. They will be there implemented. We have to empty the inside of it. We don't want to throw an exception, so just erase this part. But basically, these are the stuff that needs to exist, and we're going to fill them now. It's not going to be empty. We're going to fill the content. Another thing that we need right now is to apply a constructor. So we're going to say public circle. And this constructor will have obviously a value such as R. And then using the super constructor, which is the constructor of the shape, you can now pass this value and get the value of the R. So whenever you write this, it goes into the shape, finds the necessary constructor, and initializes it to the value that was defined there. We need one more thing. In order to calculate the circle area or perimeter, we need a variable called private double pi, which is going to be 3 point. We can also make this final because its value is not going to change. Now, to calculate the area of that specific circle, we need to obviously find an area. We can come in here and define two other variables. Protected double area, initially 0, and perimeter, initially 0. So in order to calculate the circle, we can say that area is equals to pi multiplied by not R, because R is actually initialized to A in the shape, so we use A. Be careful about that. A multiplied by A. Once you calculated this, you can return the error, and the error, as you can see, will be gone. We're going to do the same thing for the perimeter. Perimeter, which is the perimeter of the shape, as you can see, it's the class variable. We come here, we say 2 times pi times A, not R, but A. R is in the circle, but we are using the shape. Be careful. So once you have done this, we can return parameter. And this will actually finish your concrete class. So what you are doing in here is that we have a shape class, which has the abstract methods, calculate area and perimeter. We overwrite this. We are overwriting the methods. And using these methods, we are calculating the area of this specific shape. Okay, that's what I'm trying to do here. And we're going to create two other classes, which is going to do basically the same thing from their own perspective. So in the object-oriented programming, one of the most important things is reusability. You try to write the code and reuse it as much as you can. And that is the key here. So that the less code you write and the more stuff you do, the better the programming. I'm going to do the same thing for this specific stuff. So we're going to come in here and extend. Once we have extended the shape, we're going to come in here and implement the methods. You can write them manually again, or just press on implement methods, and all this stuff will come. all you have to do is to empty the content of the method. And we're going to write our own methods there. For this specific example, I'm going to come in here, make sure that I have a constructor, public rectangle. In the rectangle, we have two different values. We can call them A and B, X and Y, whatever. And we have a super constructor, of course, and we're going to pass them into the super rectangle. We pass them in here. Now that we pass these values into the shape, they actually exist here as A and B, so we can calculate the area. Now, the area of the rectangle is A multiplied by B, and you can return the area. For the perimeter, it will be perimeter 2 times A plus B. And we're going to return perimeter. As you can see, they all using the shape class, but the way that the content that they apply is different. So in rectangle, you have 2 values, where in circle you have 1 and the pi. And the content of calculate area and perimeter is different from the content of calculate area and perimeter in the rectangle. So each one of them, each shape has a perimeter, each shape has an area, but the formula inside is different. There is one more, which is called right angle triangle. And we're going to use the same idea here. Since we have done this before, I will just create this quickly. Extend shape. Make sure to implement the methods. Erase this. So coming in here. Let me open the module as well in case someone wants to join. They can see this part as well.
The only person in this conference.
So I'm going to go back to NetBeans. So in this case, we will have another constructor. This one will be right angled triangle. And it's going to be public. And it's going to have 3 different values, A, B, and C. And we're going to use the super of the in here, where it includes all 3. So I'm going to come in here, say super, which is using the shape one, A, B, and C. And as you can see, the errors are completely gone. Now to calculate the area, we're going to say something like, assuming that A and B are base and the height, I will say A multiplied by B divided by 2 is 0.0. So let's just make this like that. You can also put in here the values, base, height, and the values in there. And then if you want to pass them, you can also do this, base, height, and height. We know that base and height divided by 2 is actually the area. And we're going to return this, which will remove the error. We can also do the perimeter. Remember that when you pass them, they are the class values, but when you calculate them, use the values inside the shape. Make sure to follow this logic. It's very important. A plus B plus C will give us the parameter. Return parameter. Now we finish all this classes. As you can see, each and every one of them is completely finished, and they're done. They're there. What we need to do from here is to basically find a way to use these classes. Now, one thing that you should know, you cannot use the abstract class directly because that was actually a template for you. So this was a template for the other classes. However, you can use all these other classes to create the objects. And as you can see, the template is actually a little bit like transparent in here. You can see that the classes is actually transparent, but all these classes, the ones that are concrete classes, they're not transparent. So when you come in here to the main, if you try to create a shape object, let's say shape is equals to new shape, and try to pass a value inside, it will give you an error. You will not understand what you are trying to do because this is an abstract class, and the abstract class cannot have an object, cannot be instantiated. Okay, and if you wait on it, it will show you the error. However, any class that extended the abstract class can have an object such as circle. So you can create in here my circle, new circle, and give it a value, for example 5. And you see there is no error at all. You can do that for rectangle, my rectangle, say 2 and 4, and right, let's call it my triangle, right, and 2, 4, and 6. These are the values that I have, and you can basically use these to calculate each and every one of these shapes. Remember that while these are circle, rectangle, right angle, triangle, they are different shapes. They are regardless of extending the shape class. So just as I showed you in the previous lectures, it is possible that you can create a basic kind of like array for this and add these components inside, just as we did in the man class. So I can go back to my application for the main, and because I treat each and every one of these as shapes, it is possible that I can create an array list of shape for these specific shapes. I'm going to call it shape and my shapes. We need to make sure that the array list is defined. So make sure to put the array list there. And then as you can see, I have a shape called my shapes with the array. Now with my shapes, I can add each and every one of these into my array list. So it can be my circle, my shapes, and the next one is my rectangle, my shapes, and my triangle. So each and every one of them is added in here, and you see the shapes are already there. And now, once you have added these shapes, it is possible to do operations on them. It is possible that you can, for example, iterate each one of these shapes and display their properties, just as we did in the main class. So I'm just going to copy paste this code and slightly modify it. So in the previous example, we were doing a man for each man. Now I'm going to do it for shapes. So this should be shape, each shape in my shapes. And for this one, we're going to basically show the, just erase this, each shape with the, let's say, with the area and the perimeter. So now we came in here and we're going to show each and every one of these shapes. I want to insert the JOption pane in here just to have the Sweet library component, and we're going to show each shape. Instead of get name, we're going to get the area. So this will be calculate area, and the other one will be not each man but each shape, and this should be calculate perimeter. And you can basically get rid of this and show each and every one of the shapes. Shape area equals to plus this plus, let's put it over there, the same as the other one. So I'm just going to put shape perimeter and then close the bracket and put the semicolon. Now this will show each shape area and perimeter, but it won't show their name. So if you also want to show the name of the shapes, maybe you should put a name constructor there, or inside the, you see each and every one of them is visible. Maybe we can put into the abstract, we come in here, we can put a name for each and every one of the shape. So this will be protected string name. And I'm not going to use a constructor for this, but I'm going to use a get and set method. So you can do that by basically putting the code insert getter and setter for the name and generate. And as you generate this, the get name and set name are automatically set up. All you have to do now inside the main for each object that you created is to set a name. So we can come in here, my circle set name is gonna be circle. My rectangle set name rectangle, and my triangle set name triangle. So each one of them is set up, as you can see. Now if you want to show the name of the shape, you can simply go in there, put another line, and let's show the name of the shape, and you just need to say get name. So this will show the name of the shape, the area, and the perimeter. So let's try to run this thing. So name of the shape is circle, the area is 78.5, and then the perimeter is this. You can basically decimal format this if you want to. The second one is the rectangle, as you can see, and the third one is triangle. So this is a much better way to organize your classes. As you can see, I avoided repetition. So instead of going and adding get and set name under each class separately, I put it only once under the shape class, because I know that each shape will have a area each shape will have a parameter, and each shape will have a name. So instead of adding these things separately and making the code unnecessarily long, what I did was I created an abstract class and made sure that these are listed in there and inherited by these other classes so that they are visible over there correctly. Now, anything you don't understand, I can answer. But basically, this is going to be the format that you're going to see in your final exam. And the solution of this, a different one perhaps, is also in the slides. So you can see it over there. The slides are actually really good. So you can uh, see the code being shared over there as well. One of the things that you should know in object-oriented programming, the modern ones at least, they don't support multiple inheritance. This is again something I discussed previously, and the reason for this is because it does not multiple inheritance overcomplicates the parent-child relationship, and it might be very difficult to guess where this information is coming from. For example, when you look at this example, you know that the shape has a get name and set name and certain values. Imagine that these classes have more than one parent and they all have a name value, let's say. Then it will be very difficult for you to guess where the name value is coming to the child because the child has more than one parent. Is it coming from the shape? Is it coming from the other class? So if those parent classes has the same variable, it will be very difficult to tell from which parent the child is inheriting the values. This is why multiple inheritance is a little bit overcomplicated, especially if we have more than two parent class. It is going to be very difficult for you to tell and manage your classes. It will be overcomplicated. This is why many languages, instead of supporting multiple inheritance, they support what we call as interfaces. An interface is an abstract class that all the methods are inside are abstract. So an abstract class is something that you already know now. It means that it has a constructor, as you can see, it can have variables, but it can also have abstract methods. If you create a specific class, let's say that is abstract and all the methods are inside abstract and it cannot have concrete variables and methods, then that class is called an interface. Okay, it is relatively easy to create an interface. You just need to go there, new, and you can say interface. Java interface. You can select this and you can create an interface. For this example, it will be inappropriate to have an interface, let's say. But if you want to, for example, the circle to have the pi value to, let's say, standard circle and create this value in here, and you create a specific value for your interface. So in an interface, all the values that you create should be static and final. So it cannot have a final static double pi equals to 3.14. When you define a static final value in the interface, this is okay. But if you try to define a variable like this, integer x, it gives you an error because this is not a constant value. So one of the things that you should know about interfaces is it cannot have regular methods or variables. The only thing it can have is a static value. static and final, like the pi one. For this specific example, if you don't want to apply the pi value to here and you want it to come from the interface, you can basically say that the circle extends the shape and implements the interface. The interface we implement is the standard circle. And as we write the standard circle, as you can see, the pi is recognized now again, because the standard circle has the pi value. So if you're going to use the pi, let's say more than one calculation, and not necessarily in this class only, then you can basically define it in here, making it available to every class that implements this standard circle. And this can come with other stuff as well. If you want to add another method in here, it cannot be a method of setting or getting a variable. Normally, for example, you can insert the code and here say get and set, but for interfaces, this is not true. If you're gonna create a method, it has to be abstract, even if you don't write the keyword abstract in front of it. So even if I don't write the keyword abstract, as you can see, it is still regarded as an abstract method. This is an important feature of interfaces. As a matter of fact, you have used an interface before, but perhaps you didn't know that it was an interface. So if we go our previous exercises, such as form exercises that we have done before, let's just open one. You see that you have implemented the interface of action listener several times before. So when you look at this format now, it's more familiar to you. Look at here into the circle. Circle extends shape, implements standard circle. And the standard circle is actually where I wrote the pi one. This is an interface, and the other one is a class. So basically, when you are creating the forms, you are extending a class and implementing an interface. Now, the action listener interface has a method called action performed, but the body of action performed is never defined because it's an abstract method. You will define how this method will function, and hence this is how it is formed. Now, this structure that you have been writing for so long ago should make more sense now, because you now know that the classes can extend other classes, and they can also implement interfaces. Okay, just as we did in this circle exercise. Instead of writing the pi value, what I did was I extended the shape and implemented the interface. Now, do you have any questions? Is this clear? As for the exam, I am going to give you a UML class diagram. Okay, all of these are covered concepts, so have a look at them. We all covered all of this. I just didn't solve perhaps the exercises at the end, but because summer school is such a rushed and a fast version of the regular term, we don't really solve much exercises. I just talk about the generic concepts, okay? But I will give you some hints on the final exam. The final exam will be very similar to the exercise that we have solved today. And instead of me giving you these, regular shapes and stuff, I will give you the UML class diagram. So all of these will be given to you as a UML class diagram representation with the, abstract and concrete classes. So there can be an abstract class, there can be an interface, there can be a concrete classes, and you will have to generate the hierarchy based on this specific figure. Okay, so you will be given an explanation as a UML class diagram. And using that, using the class diagram, you will have to understand the hierarchy, how these classes are basically structured, and generate them in Java code. And you will also be asked to create objects for them. And all these information will be given to you, such as I will tell you, for example, that you have to create a circle with 5 radius, and the pi value is 3.14. So all this information will be written down and given to you, but you will have to create the classes themselves. You will have to basically generate the class hierarchy in terms of Java code. Okay. For this, you need to understand how the UML class diagrams are represented. Just once again, you will need to understand the top parts. Make sure to understand if it's a conquered class, it's just regularly written. If it's an abstract class, it's bold and italic. And if it is an interface, it will explicitly say that it is an interface. You will need to know the symbols, such as plus means public, hashtag means protected, minus means private, and all these features, all these methods, you will need to read them. You will need to make sure that in the class hierarchy, the abstract class will be inherited by the child classes. So in the regular class, it will never show you, for example, area and perimeter, because those are already written down in the abstract class. So you will need to understand the UML class diagram for sure in order to answer the question. I will not ask you drag and drop features or something to design yourself. I will not ask that because those are very well covered in both of the projects. My focus in here will be basically pure object-oriented principles, like how do you put get and set methods? How do you understand the UML class diagram and then implement it into Java code? What is polymorphism? How can you modify this? What is an abstract class? Which classes have objects? Which classes do not have objects? All these stuff, all the concepts that we defined and we discussed, it should be basically formed, broken down into one question with several sub questions within. You will have an hour to finish the exam, okay? And you can, of course, use NetBeans during the exam, but you will need to understand exactly what's going on there. Otherwise, if you don't study and come and you just expect to understand everything during the exam, the time wouldn't be enough for you. So sit down, make sure to understand all these concepts very well. Look into the more tutorials given, even online videos and exercises. I think that will help you a lot. And of course, you should know this stuff from your projects as well, because I have given you 2 different projects which I assume you have completed. And yeah, that will be enough. Your exam is tomorrow at 12:30, which is like almost in 24 hours. Okay. And then when I check your exam and the projects next week, you will be done with summer school. Now, before I end up this section, do you have any questions? I will upload this video to YouTube, of course, so you will be able to watch it. But do you have any questions? Okay, thank you for coming. Since you don't have any questions, I'm going to end up this session. Thank you for coming and good luck in your exam. Take care.